Welcome to our deep dive into the world of generative AI, transformers, and large language models, where we'll explore cutting-edge technology shaping the AI landscape today. In this video, we'll walk through the rise of generative AI, its revolutionary impact through models like ChatGPT, the role of key players like OpenAI and NVIDIA, and how technologies like Grok are pushing boundaries. So, let's get started with how it all began and where it's heading. Generative AI, in simple terms, refers to AI models that generate content such as text, images, and even audio that mimics human-created content. The history of generative models dates back decades, but it wasn't until the last few years that they entered the mainstream. Early AI models were mostly based on rules, deterministic algorithms, and pre-programmed logic. However, generative AI models utilize neural networks to generate new data patterns based on the input they've been trained on. A major leap came with the development of models like GPT, generative pre-trained transformers, first introduced by OpenAI in 2018. But the launch of ChatGPT in November 2022 marked the watershed moment when generative AI became a household term. Suddenly, everyone was interacting with an AI capable of holding sophisticated conversations, writing essays, generating code, and more. ChatGPT's launch ignited a race among tech companies to build more advanced and powerful AI models, cementing generative AI's place as a transformative technology of the 21st century. OpenAI, the organization behind GPT and ChatGPT, was founded in December 2015 by tech luminaries like Elon Musk, Sam Altman, and others with a mission to embure that artificial general intelligence benefits all of humanity. While Musk stepped down from the board in 2018, Sam Altman, the former president of Y Combinator, took on a pivotal role in steering OpenAI's vision. Under Altman's leadership, OpenAI shifted from its initial non-profit structure to a hybrid for-profit model, drawing massive investments to fund the research and development of AI models. The release of GPT-3, a language model with 175 billion parameters, and its subsequent integration into applications like ChatGPT made OpenAI a significant player in the AI space. Sam Altman, with his strategic thinking and long-term vision for AGI, continues to push OpenAI toward new horizons, focusing on creating AI that can not only respond to queries but also solve complex tasks across industries. As OpenAI and other companies developed more complex AI models, they needed significant computing power to train these massive models. That's where NVIDIA comes into the picture. NVIDIA, traditionally known for creating graphics processing units for gaming, quickly recognized the potential of GPUs in the AI field. Unlike traditional CPUs, GPUs are highly efficient at performing parallel computations, which are essential for training deep learning models. In the AI arms race, NVIDIA's GPUs became the gold standard for training machine learning models, particularly for generative AI and large language models like GPT. NVIDIA's CUDA cores, Tensor cores, and advanced parallel processing capabilities have accelerated model training exponentially. This surge in AI demand catapulted NVIDIA's stock to new heights, establishing it as a key player in the AI infrastructure landscape. As LLMs continue to grow larger and more complex, the significance of NVIDIA's GPU technology remains unparalleled. The key to the rise of generative AI lies in the transformer model, introduced in a 2017 paper by Google researchers titled, "Attention is All You Need." Before transformers, models like RNNs or recurrent neural networks and LSTMs, long short-term memory networks, were dominant in natural language processing or NLP. However, these models struggled with long-term dependencies, often leading to inaccurate predictions for longer sequences of text. Transformers changed the game by introducing the self-attention mechanism, which allowed the model to weigh the importance of different words in a sequence, regardless of their distance from each other. This ability to capture relationships across long contexts gave rise to more accurate and context-aware language models. It wasn't long before transformers were adopted across NLP tasks and later evolved into the architecture behind GPT, BERT, and other advanced models. The introduction of transformers revolutionized the field of NLP and made today's generative AI systems possible, paving the way for the groundbreaking capabilities of ChatGPT, Claude, and other models. The architecture of transformers and LLMs. At the core of transformers lies the concept of self-attention. When a transformer processes an input, such as a sentence, it uses self-attention layers to assess the relationships between each word and every other word in that sequence. Unlike previous models, transformers do not process input sequentially, instead they handle entire sequences at once, making them faster and more scalable. Transformers also include multiple layers of encoders and decoders, allowing them to handle both input and output effectively in tasks such as translation or text generation. The architecture scales beautifully, which is why we now have large language models or LLMs like GPT-3 and GPT-4, which can handle massive data sets and produce highly contextual responses. Large language models like GPT-3, Claude, and others are essentially giant transformer models with billions or even trillions of parameters. These parameters allow the model to learn language patterns, context, and nuances through vast amounts of data. As a result, LLMs can perform a wide range of tasks, from answering questions to generating creative content. It's this architecture that has unlocked the incredible potential we see today in generative AI. ChatGPT versus Claude, a comparison. Now let's compare two of the most well-known generative AI models, ChatGPT by OpenAI and Claude, developed by Anthropic. Both of these AI systems are based on transformer architecture and excel in generating human-like text, but there are key differences in their approach and use cases. ChatGPT, part of OpenAI's GPT family, has been designed for general-purpose language understanding and generation. Its main strength lies in its ability to converse, provide detailed information on a wide variety of topics, and adapt to various tones and styles. ChatGPT is versatile and is used in many applications, including customer service, education, and content generation. It is continuously fine-tuned with user feedback, making it an evolving conversational agent. Claude, on the other hand, takes a different approach. Built by Anthropic, a company founded by former OpenAI employees, Claude focuses more on ethical and safer AI interactions. The model is designed to be less likely to produce harmful or biased outputs, with a strong emphasis on aligning the model's outputs with human values. This makes Claude an appealing choice for businesses that prioritize safety and alignment in AI applications. In terms of performance, both models excel in generating coherent and contextually appropriate text. ChatGPT might offer more versatility due to its wide-ranging applications and larger user base, but Claude stands out for its focus on safe AI deployment and fine-tuned ethical considerations. Grok and the concept of LPU. As AI models continue to scale, the demand for specialized hardware to handle these massive computations grows. Enter Grok, a company that is developing the next generation of hardware for AI, particularly around the concept of the LPU, the Tensor Streaming Processor, or TSP. While GPUs are currently the go-to solution for training and running AI models, Grok aims to push the envelope by introducing hardware that is specifically designed to accelerate AI workloads, including generative AI and LLMs. The LPU, or Language Processing Unit, is Groku's answer to the limitations of current hardware. LPUs are designed to work in tandem with models like transformers, optimizing the computational load by streaming data more efficiently and providing higher performance with lower power consumption. The LPU architecture allows for faster training times, reduced latency, and the ability to handle increasingly complex models. While still a relatively new player in the AI hardware market, Grok is quickly gaining attention due to its innovative approach. As AI models continue to grow in size and complexity, hardware innovations like the LPU could be key to unlocking the next wave of AI breakthroughs, particularly for real-time applications and edge computing. Conclusion. In conclusion, the journey of generative AI, from early language models to the cutting-edge capabilities of ChatGPT, Claude, and Groku's LPU, is a testament to how far we've come in understanding and mimicking human intelligence through machines. OpenAI and Sam Altman's vision, NVIDIA's GPU dominance, and the revolution sparked by transformer architecture have all played crucial roles in pushing AI to new heights. As we look toward the future, the continued development of specialized hardware like Groku's LPU and ethically aligned models like Claude will be critical in ensuring AI's responsible and powerful evolution. Thank you for joining us on this exploration of Gen AI transformers and LLMs. Stay tuned for more on the fascinating world of artificial intelligence.